So today what I would like to do is to talk to you about the global budget of ozone and determine what really drive the changes in ozone and what we could do to perhaps reduce these secondary pollutant from the atmosphere. So what I'm going to do is to talk to you a bit about the trends that we derive from observation, trends of ozone, of course. We were going to try to see what the mechanisms are that drives to these changes, and then we will take, as an example, an accidental, basically changes, major experiment at the size of the planet, where due to the pandemic, the emissions of ozone precursors were severely reduced. So first of all, let's say a word about trends and observations. And of course, trends in ozone are closely associated with the trends that we see, for example, in nitrogen oxide or in organic compound like the VOCs, and of course also related to the presence of particle matter, the PM. Now, we have a lot of data about ozone already. They're coming both from surface monitoring station or from satellite. You see here, for example, the evolution of ozone in eastern China, and you see basically going from the winter, the spring, the fall, the summer and the fall, and you see, of course, the large amount when the sunshine is present and ozone is produced. We also have observation station at the ground. And you see here a number of indicators that are basically telling you that the number of days, for example, where we have too much ozone, more than 70 ppb, is relatively high still in China, but still also in parts of basically California and northern Italy in Europe. So every country still has to do quite a bit of work to reduce its level of ozone. Now, if we look at the trends over time, you see here, for example, that the situation is evolving, of course, from region to region. In the eastern part of North America, we see a slight decrease in ozone, pretty steady in Europe. But in China, we have seen an increase in ozone, and this increase has accelerated really since about 2012, 2013, when drastic measures were taken to reduce in particular the level of particles in the atmosphere, of aerosol particles in the atmosphere. You see here another graph that shows you also that there's been a reduction in different parts of the world, but there is now an increase in China associated as kind of a byproduct of the measures that were taken to reduce the particles. So that means that we have to understand the complexity of the chemistry, the relation between different processes, and what really drive the presence of secondary pollutant like ozone or some of the aerosol that we find in the atmosphere. And this graph here shows you this complexity and the formation, the mechanism that lead to the formation of ozone that are of course associated with the emission of VOC, of NOx, but also of sulfur here in terms of, in particular, the formation of particles. But there are interactions between the particles and the gas phase chemistry, and we have to understand all these mechanisms in order to be able to take the appropriate measure to reduce air pollution. So let's talk a little bit about the mechanisms that are involved, and I will not talk about all of them, but give you a few examples. This graph here that you see shows you essentially the level of ozone as a function of the amount of nitrogen oxide, one of those species that are released, emitted, and the VOC that are also released. So let's take two examples. Let's assume that we have a lot of NOx in the atmosphere, as is the case very often in China, and in particular in the wintertime, and we reduce NOx. What do we see? An increase in ozone. But if we have less NOx, maybe if we decrease NOx further, we see less ozone produced. And of course, you could play the same game by changing the VOC. And so it is a matter of exactly how to balance the reduction in those primary emitted compounds to get to a minimum ozone. So the emissions are very important. And so we have now much more information about emissions. This is here a global emission map that we have available, and of course you see the high value over China, over India, over Europe, over the US. You see the ship tracks. Ships are a big emitter of nitrogen oxides. We can zoom a little bit over Asia. We can zoom further to see what happens in the region where our meeting is taking place here in southern China. And you see, of course, the importance of traffic through the road that exists. Now, these emissions are known, but have they changed as a function of time? Well, eventually exists. Tsinghua University, for example, has done an excellent job in looking at the trends in the emissions. You see here sulfur, drastic changes, which of course improve the situation for particles. NOx has changed quite a bit, but others might not have changed so much. Agricultural ammonia has not changed, for example, or the VOC has even increased a little bit. So we can use model to try to look at the impact of those changes. So let's take a model that shows basically what would happen if we would reduce or suppress the anthropogenic emission and how ozone would respond to that. And you see that in the summer, of course, ozone would decrease, less NOx, less VOC, you would have much less ozone. But in the winter, the situation is different. You would see here an increase in ozone in the northern part of China and a decrease in the southern part of China. By the way, is this something that happened during COVID-19? We will see. Of course, you could also look at what would happen if you suppress the agricultural emission of nitrogen oxide and ammonia, and particularly in the summertime, you would see a decrease in ozone. So there are a number of mechanisms, possible mechanisms that we need to consider to understand. I mentioned already the NOx and the VOC, which of course play a role in the nonlinear production of ozone mechanism. But of course, we have to deal with the impact of aerosols. And here we have to highlight in particular that by reducing basically aerosol, we reduce the scavenging of a number of species by the particles. That's reduced, and that leads very often to an enhanced formation of ozone. And then, of course, if we reduce SO2, as we see it's happening, it has an impact, for example, on the balance between ammonium sulfate and ammonium nitrate. And finally, we should not forget the role of meteorology. So there have been some studies to estimate this, and this is a Harvard study here that shows, for example, that the changes between 2013 and 2017 in ozone can be explained in theory by a number of processes. But the fact that the PM is changing has an impact on essentially the level of HO2, which is one of the key ingredients in the production of ozone, and that could explain a large of the ozone changes that we see in northern China during summertime in particular. But let's see a bit now at this big experiment that took place, the COVID-19, which reduced the emissions of a number of species, and the reduction of those emissions has led in particular to an increase in ozone in northern China and a decrease in the southern part of China. Now, the decrease in NOx has been seen. You see here at the top from CHOP-OMI and OMI observations that the value of NOx were much smaller in 2020, January to March, compared to the situation here in 2019. And of course, we can use a model and we can try to simulate essentially the reduction that we have estimated in the emissions through a study of the economic indicator during the COVID period. And what you see essentially is that in February, when China was locked down, you see a relatively large reduction here, 40–50% of the level of NOx, not very much occurring at other regions. But as time goes, March, April in particular, where the whole world was locked down, you start to see that the reduction in NOx occurs at other places, not so much in China anymore at that time. So what happened to ozone? Well, ozone changes is shown here from the global model. This is the model that was run at NCAR, in fact. And you see that in February, we have exactly what the old models has suggested when we reduce anthropogenic or industrial emissions. Increase of ozone in the north part, decrease ozone in the southern part, and then this fades away, and then as time goes, because of the reduction of NOx and other primary compounds during this period, you see a general decrease in ozone that is occurring of just a few percent. Now we have, of course, to understand what happens. Perhaps first we see here in a zoom the increase in ozone in Northern China, the decrease in Southern China. And in fact, if we look at observation at the surface stations that we have collected in Hamburg, you see that after the pandemic started, basically we had a reduction in NO2. You see, this is before the pandemic, this is after or during the pandemic. You see the reduction in NO2, and you see the increase here in ozone that has occurred, and that was measured. You see it also here when you look at the average diurnal variation of a number of chemical species before the pandemics, during the pandemics. You see that the particles have been reduced, you see that NO2 has been reduced, and you see that ozone has been reduced. So this is really confirmed and basically tries to validate basically the understanding that we have. Let's go quickly to the conclusion by saying that essentially the response in ozone to reduction of NOx varies with location, with season, with chemical regime, and also with the level of particles that we have in the atmosphere. In the summer, a reduction in PM tends to reduce the scavenging of HO2, which is a radical that leads to the production of ozone, and therefore tends to increase ozone. In winter, the reduction in NOx reduced the titration of ozone, that also increased the level, of course, of ozone. And I think we can say that the COVID experiment gave us a good opportunity to look at essentially how the atmosphere responds to dramatic changes in the emissions. And that should be very important for essentially the policy action that need to be taken to improve the air quality situation, and in particular to kind of constrain the changes or the increase in ozone concentration. Thank you very much.